Software Quality and Productivity with Capers Jones.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and run your software with confidence in Azure, all while using everything the .NET ecosystem has to offer. And I continue to do a ton of online user group speaking at least once a month now for the last year and a half. So if you run a .NET or Azure-related user group, I'd love to give a presentation for you. And our sponsor, ClearMeasure, they make this podcast happen, and they're a software architecture company that empowers .NET teams to be self-sufficient and able to deliver world-class results. So if they can help, please get in touch. And also be sure to check out the new video show, Architect Tips. And I am so excited about our guest today. Our guest is Capers Jones. And Capers Jones is a software engineer and prolific researcher and publisher. He's written over 17 books on software engineering, software metrics, and software best practices, covering quality, productivity, and many other topics. He is a founder of Namcook Analytics, which is an international software consulting company where he currently serves as the chief scientist. And Mr. Jones has spoken at numerous conferences and also advises international governments in software engineering. Capers started his career as a software engineer in the Office of the Surgeon General for the United States, but found his passion for research and advisement at IBM, where he developed methods of large project cost estimation, as well as methods for productivity and quality measurement. And today, Capers continues to publish and speak and advise while he bridges the learnings and data of over 20,000 software projects to modern tools and languages and software challenges. And his latest book is coming out in August of 2021. That's just within a month of this recording date. And the new title is Software Development Patterns and Antipatterns. You can pre-order that online now, and we'll include a link to it, as well as a link to some of his articles in the show notes. And I'm so excited to have you on the show. So Capers, welcome to the show. How are you, sir?
I'm fine. Jeffrey, thank you for inviting me today.
Oh, my pleasure. My pleasure. Your name has actually been mentioned several times on various episodes of the Azure DevOps Podcast, and our audience is always interested in better ways to move faster and deliver consistent quality so that software systems are just more reliable running in production. And you, before we jump into the research, I always like to ask the guests kind of the background. What led you into going really deep into your field? And you just had such a pronounced career over the multiple decades. Can you share some of the high points that's happened along your career, and what kind of led you into software research?
Well, I went to the University of Florida, and then after that, I was working for the Office of the Surgeon General in Washington as an editor of a medical magazine. And they were just beginning to convert paper records into computer records. And they didn't have programmers who understood medical terminology. So I was asked if I would like to go to IBM and learn computer programming to help in the conversion of medical files into computer files. So I did. I learned programming, and after a few years, IBM asked me to join itself. So I went to work for IBM as a software engineer and researcher. And not long after that, IBM started building really large systems. In the old days, in the 1400 days, applications were fairly small, several thousand lines of code. But as the 360 and 370 and the modern machines came up, applications were hundreds of thousands. And it turns out that the bigger the software package, the more bugs there are in it. So the chairman of IBM, Thomas Watson Jr. at the time, was getting a lot of complaints from customers about poor quality in IBM deliverables. So I was asked, together with a lot of other people, if I could find some ways of improving the quality of IBM's major software packages. But in order to do that, you have to know how many bugs there are and where the bugs are coming from. So we started doing an analysis. And fortunately, IBM had been keeping very good data, so we had good information available. And it turned out that bugs in the code itself were less than half of the total number of bugs. And for really serious bugs, things that cause customers the most grief, the majority of those bugs either came from poorly understood requirements or missing requirements or errors in the design. And then we discovered, too, that there was another category. When you thought you had fixed a bug, in about 10 to 15% of the fixes, you put a fresh bug back into it. They were called bad fixes. So in order to make a real improvement in quality at the bottom line, you had to start early with better requirements. You had to use better design, and you had to, of course, use good coding practices, but you also had to minimize bad fix injections. And it turns out that testing by itself isn't sufficient to do this. So what we did at IBM, we started with design reviews, requirements reviews, design reviews, code inspections, and we also inspected every fix before it was introduced into the software application. And as a result of that, we were able to lower the number of bugs that IBM delivered to customers by well over 50% in a couple of years. And that paid off well enough so that IBM decided to teach the same materials at every IBM location and then to write public books about it for their customers. So IBM asked me to write a couple of books on improving quality, which I did back in the early 70s, and they were published by IBM. And then later, other publishers came to me and asked for books, and McGraw-Hill and Prentice Hall and all the regular book publishers wanted some books too. So I ended up with 17 of them over the years.
That is a lot of books. And when I first came upon your work, I believe it was from the book Applied Software Metrics, and then
Applied Software Measurement.
Applied Software Measurement.
About halfway through the series, yeah.
And then moved on to Software Engineering Best Practices.
Yes.
And just to guide people who are going to invariably look up your body of work, how should they progress through your books? Or are there some books that kind of completely take the place of earlier books? How should they think about all your 17 books?
Look at the publication date. Books written in the 1990s are fairly obsolete today. You can start with the publication date and work backwards. So the one I just sent you today is going to be published in 2021. That's Software Patterns and Antipatterns. It isn't even out yet, but that'll be certainly a modern one. And then books published in 2018, 2017, anything more recently than about 2017 should be still have valid data. Of course, there was a big gap in collecting data in 2020 when live consulting stopped because of the virus. Mm-hmm. We only had to depend on telephone calls and remote data collection. So 2020 is kind of a bleak year for data collection for software.
Let's talk about your book that I guess will come out sometime this year, hopefully sooner rather than later.
Yes, the authors, my part is done, the publisher's doing it, and I don't have any further control over it, but it'll probably be another couple of months. They sent me a word, which I sent to you, that the publication process was in full swing, and now was the time to start talking about it, because that means usually that it'll come out in a couple of months.
Well, we'll make sure to include all the information in the show notes, but tell us the title again of the book.
It's called Software Patterns and Antipatterns.
And what's the goal, or what's the mission of this book?
Well, the goal is to point out the patterns, things like DevOps and Azure that are beneficial, and the antipatterns, the things that are harmful to software, like failure to do inspections, failure to do static analysis, inadequate testing, things of that sort.
There's a lot of people who are kind of getting the message that, you know what, we should automate the conversion of software code from the text files into buildable or deployable packages, and automate the things that need to be done over and over again, and even automate testing. But that's not the full story. Your research shows some of the key practices that need to be in every team, regardless, the rules of thumb, which ones in your research have kind of elevated up to the point where you would say, you know what, every team really should do, this practice and that practice and this other one?
Well, it's not quite as simple as that, because what you need to do is based on how many people the total team consists of and whether they're in one building or scattered throughout the world. For small projects with, say, less than 10 people in one building, you can have face-to-face meetings these days, now that everyone's vaccinated. You can have face-to-face meetings. You can do local design reviews and requirements inspections. And you can discuss testing and progress and do it on a weekly basis, and things will go smooth. But when you get over 100 people, and especially to really big systems with several hundred people, and they're scattered through 10 or 15 different cities, sometimes in different time zones, then you have a lot more complicated issues to deal with. First, big applications have a lot more bugs in the first place. The number of bugs in an application goes up with the almost a square of the size. So the bigger the system, the more bugs you have. And then because of the geographic distances, it's not as convenient to do things like live inspections, but fortunately you can do Zoom inspections and do things remotely. But you also need to record all the bugs that you found and use the data for defect prevention for future applications of the same type. So it's a complicated series of steps based on how big the application is, how many countries are involved, how many people, and of course, the nature of the software itself. Business applications are fairly easy, but there are some things having to do with cutting edge technologies like space flight or medical research, where you don't have all the understanding of the topics that need to be included in the software. And those are a great deal more difficult to do correctly.
You'd mentioned the square of the size as in lines of...
It's not quite that. I have the actual formula, but I can dig it out and send it to you.
But somewhere in that neighborhood. It's not linear, it's more exponential.
Yeah.
Is the point.
Yeah. The bigger the software, the greater the volume of bugs.
Okay.
And it's not a linear progression.
Have you found whether or not there's data about this? Have you found a difference in the trend of bugs for people who have decomposed software system into multiple smaller parts versus keeping them all as a part of one code base? In other words, the microservices movement.
Big systems have to be decomposed. It's basically impossible to build a large application as one big chunk. They have to be decomposed into components and then modules and submodules and routines. But that's today an art form rather than a science. And so how you go about decomposing is really based on the skill of the developers and whether they've seen the same kind of application before. If you've seen the same kind of application, like compilers, 10 or 15 times, you know how to decompose it. But if it's some brand new thing, like one of these SpaceX things that's going up, or looking for analysis of a virus and what causes infections in research hospitals, you don't really know the things, and it's a lot more complicated.
Gotcha. You've written about defect prevention techniques, and you mentioned testing and static analysis and inspections with them.
Well, those are defect removal. Defect prevention comes primarily from reusing modules from earlier applications that have proven to be zero defect. And the more pieces you can put together from existing applications that are known to be bug-free, the smaller the amount of work you have to do yourself. And of course, that reduces the chance of new bugs because you know the bugs are gone from the application that's already been fully tested and deployed. So it's reusability is what you need.
Okay. So defect removal are the other ones mentioned.
Okay. Defect removal, the industry started primarily depending on testing, but testing really is not sufficient because the bulk of the bugs, over half of the total bugs, originate in requirements or design or in bad fixes, which are new bugs accidentally injected while attempting to fix an old bug. So if you look at the distribution, requirements bugs are maybe 15%, design bugs maybe 35%, coding bugs 30%, and bad fixes are the remainder. So you need to start early and work on both prevention and removal of requirements and design bugs, and that will minimize the number of bugs in the code, because a lot of the coding errors are really derivative from improper design or missed requirements.
Okay. So are there any of the defect detection or defect removal techniques that for enterprise developers or people writing business applications where you would say, you know what, 80% of the time you should employ these practices?
Well, once again, going back to size, if it's a one-person application, you can hardly do team inspections because it's only you. But the bigger the application, the more you need team inspections and requirements reviews and design reviews. And for testing, you can develop automated test cases that will actually do a good job of code correctness. But if the code is missing a requirement, the automated testing can't find missing requirements because it doesn't have any way of knowing about them. So you need something more than automated testing. You need to start looking at the front end of the process and being sure that you have the full set of requirements. And therefore, requirements reviews or inspections, design reviews or inspections are critical to having the code correct.
I can hear some of the listeners immediately asking, well, shoot, nobody's ever shown me how to do a design review. Okay, I want to do a design review. What the heck does that mean? What do I do?
Well, there are actual quality assurance consultants who teach it. And also the bigger companies, AT&T, ITT, IBM, Huawei in China, they have internal software education groups that teach new developers how to do things like design reviews and code inspections. As a matter of fact, that's another point. Software engineers need something like 8 or 9 days of training per year once they're employed to stay up to speed with the latest technologies. And some of that training will come from their own in-house faculty, but other training will come from guest experts. You bring in people like Barry Bain or Juan Humphrey, who was one of the developers at the Software Engineering Institute, and they will teach your people the best methods from around the industry. So it's a combination of internal education and guest experts from around the world.
Okay. And when one of the ways that I've been advising people to implement the formal inspections of the code that you mentioned was with the DevOps approach, the pull request, where requesting to pull in the code from a branch. Are there ways of implementing the formal inspection that you've seen work really well?
Well, what you just suggested sounds good. Normally, you should have a training program before you start, and you should have, for inspections that are, say, 6 or 8 people, you should have a couple of beginners in the inspection so that they can learn from the experts. And for their first inspection, they can see how it's done by participating with inspection with top-tier experts.
Okay.
By the way, this is the way medical doctors are trained.
Yeah.
It's the same kind of concept.
Yeah, it was. I was actually having dinner last night with some parents of classmates of my children. One was a surgeon, and I related to him. In the software world, a gentleman named Fred Brooks wrote an essay called "The Surgical Team," and I told him the nature of it. And I said, in your world, you can't get 20 surgeons in the operating room and expect for that operation to go any quicker.
It's similar in concept, except, of course, a human life is more valuable than a software package.
Yes. And then, of course, the ladies at the table, then we turn and it's like, yep, and you can't make a baby by going and getting 9 moms.
Yeah, that's right, you can't.
So, well, the other practice that you've mentioned a lot is static analysis. And, there's static analyzers all over the place, like SonarQube and others. What is your thought process on static analysis today, and what are you seeing the data show?
It's a good way of activating and finding mechanical problems in code. It won't find, as I said, missing requirements, but it can find all the mechanical things like adding a column of numbers and missing the total or using the wrong variable. So static analysis is good at finding basic problems, but not problems of missing content.
Mm-hmm. Okay. So your latest book, are you seeing any confirmations of past research or things that are changing in recent years that are showing up in the data?
Well, whenever I do a book, I try to stay current with the things that are changing. And one of the things that changed last year was the fact that so many developers are now physically separated and working from home until they could get vaccinated. And what is the impact of working remotely as opposed to working side by side? And there isn't a lot of data on that yet because it's still too recent. But it looks as though quality hasn't benefited from a lot of individual homework because it's made it difficult to do effective reviews and inspections. I mean, a Zoom thing like this, once you've done enough of them, it becomes second nature. But the first couple you do, you need a little practice.
Right. Well, there's a lot of the pendulum swing. There were remote or physically separated people, and then the Agile movement says, no, let's get everybody together in a room. Let's focus on communication. And then now it's back to remote work again because of a disease.
One of the things you're dealing with Azure and DevOps. Microsoft's Azure is a rich environment, but it's so rich and so complicated that it's hard for novices to understand how to get started. And they have so many pieces, so many tools that do more or less the same thing. It's hard to select the right set and get it right unless you've done several systems with it. So people using Azure and DevOps need a lot of training when they first begin to get started because it's not a trivial thing to learn.
No, you have that right. Actually, one of our previous guests was working on the services part of the Azure team, and I flat out asked, there's so many pieces. Is there one piece that most people should be going to first? And he actually gave me an answer, and he said, yes. Most applications can run very nicely in Azure App Service. There's so many options for all the other stuff, but most of them can run nicely using that, which is a great piece of information.
Yeah. Well, we at IBM and more recently like to start by working more or less backwards. But what you really want to do is to deliver the correct outputs to the users. So you concentrate on exactly what the users want to see, what the output should be, and then you work backwards on how you create those outputs and make sure that they're going to be created correctly all the way through the process. And the inputs is the last thing you deal with, because if you know the outputs properly, it's easy to tailor the inputs. If you start working with the inputs, you'll end up building systems that have a lot of useless features because it turns out nobody wanted it as an output, but you're collecting information that has no real value. So if you do it backwards, starting with the outputs, you'll have a leaner set of more explicit requirements that are really, really needed by the users.
How do you see that manifested when systems are actually being developed, starting with the outputs? That sounds like test-driven development a little bit, where you start with what the test should do, and then you go and actually make the code do it, but that's in the small.
Well, at IBM, ITT, and some of the others, the future clients of the software sometimes participate in reviews and inspections to make sure that the team is going to deliver to the user what they want. If you have a wall between the client and the development team, you're going to end up with misunderstandings and a high probability of not giving the users what they really want. So you bring the users in. Of course, it's tricky if it's commercial software and you're going to hope to sell it to them. But for internal applications, you can have the users participate in the reviews.
Okay. I remember that was one of the tenets of the Agile Manifesto, including the customers in the conversations 20 years ago. So,
well, the Agile folks had a lot of good ideas. Agile worked very well on small applications, but now it's working, moving up, working well on bigger applications too.
Mm-hmm. I've seen, and maybe you can confirm or reject this, but I've seen teams of really even only 10 or 15 developers produce applications that are 500,000 to 1 million lines of code. So applications can get really big, really fast.
But if you have to do it line by line and page by page in the specs, it takes too long. That's where reusability comes in. what you want to do is to collect from a library of standard certified reusable pieces, the ones that can actually be plugged together, and you know they're going to work because they work for several previous applications. And so most big companies actually have their own private library, and you can also buy reusable materials from commercial sources.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
Now, when you think about the mid-sized company, the company that maybe 5 or 10 developers is all the developers that they have. They can buy off-the-shelf components, or they can get a NuGet package, an open source library or whatnot. What's the advice for them, given what you found in the research?
Well, one of the problems with packages and sometimes open source is until you acquire it, you have no real idea how well it works and whether it has hidden problems. So I suggest that you do as many reviews as you can of the literature or from previous customers who have used the application, and or use the pieces that you want to acquire and see if they're happy with it. And you want to do a due diligence on anything that you're going to bring in for embedded into your own software to be sure it works and is not causing grief with the clients.
The cost of defects, and then you have to fix them, but maybe they came from the component. That's an unestimable cost.
One problem with cost per defect as a metric is that you still have to pay for reviews and inspections, even if you have zero defect software. So if you had a team that did full reviews and full inspections, you spent $1 million on it, and you only had one bug, the cost per defect would be $1 million.
Right.
But it's really a very high quality product. So cost per defect penalizes quality, and it makes buggier applications look cheaper than they really are because the cost per defect drops as the number of bugs go up. So that's why I like to use a metric that's independent, that actually shows the value of software economics, like defects per function point instead of defects per line of code. Because as quality gets better, defects per function point gets cheaper and cheaper, whereas defects per line of code gets higher and higher.
Talk about function points in the modern world. I think that a lot of developers don't use function points and don't use really any objective measure for software size. So how do you see people applying that today?
Well, they don't use objective measures of software size. They don't do inspections. They don't do reviews. And that's why there are so many major software failures and so many lawsuits for companies that put out software that doesn't work very well. To me, it's like being a doctor. If you're telling me that there are doctors that don't want to wash their hands before performing surgery, I'd say they're in the wrong kind of work. So if you're telling me that developers don't want to do inspections, they're probably in the wrong kind of work too.
Well, let's say I'm hearing a development manager out there who's listening to this podcast, and they're saying, okay, how do I know how big the software system is going to be, how big my project is, and how do I know if my team is going fast enough, or if they're the slowest team on the planet, or if they're above average, if the quality they're producing is average, is better, is worse?
Well, fortunately, there are commercial tools that can predict the application size before projects start, can predict the number of bugs that are going to be found in it, predict the number of lines of code that will be taken in any known language or combination of languages, and also even produce predictions of the volume of the paperwork, how many pages will be in requirements and design, and how many pages of user documents you're likely to have. So there are quite a few companies that sell tools like this. Barry Bain was one of the first back in the early 70s with his Kokomo, constructive cost model, and there's now quite a few others that are on the market. I'm in that business myself, but I don't want to sell my own products, but that's the business I started in. I built IBM's first estimating tool, which they didn't sell because they regarded it as a proprietary tool. But I've been doing that kind of predictive work since the 70s.
Well, my next question would be, okay, what's your favorite tool? And of course, it should be your own. So why don't you talk about it? Because people need to know which ones
it
they
is
are.
my own, but I've looked at all the others, and my clients have asked me to, and I'm pretty happy with the results of all of them. The question is somewhat similar to, is Pfizer, Moderna, or Johnson & Johnson the best vaccine? They all work. Some are a little more effective than the others, but these tools all work. And it's the differences are not as significant as the fact that they provide great value, great benefit. So I'd rather be vaccinated with Pfizer than Moderna than not vaccinated at all. And I'd rather use any of the tools than not use any of them.
Are they significantly different in cost?
Different in cost? You mean the tools themselves?
Mm-hmm.
A couple of them are public domain, and others, the ones that sell for a fee, are usually in the same ballpark. Okay. You can buy an individual tool, or you can buy site licenses.
Yeah. Can you give us?
You're talking several $1,000s for an individual, and more than that for a site license.
Can you give us a quick overview of the names of these tools and how they function?
Well, they start with a series of questions, sometimes multiple choice questions on is this application to be used but inside your company, or is it to be sold to outside people? Is the development team, is it going to be in one city, or the developer is going to be scattered geographically? And if they're going to be scattered geographically, how many places will they be? And do you plan to use the language COBOL, Fortran, Java, Jovial, or any of the others? So you need to identify the languages that you're going to use. And then you need to identify the nature of the application itself. Is it a military application? Is it an internal business application? Is it system software like a compiler? So you need to identify that. And there's about 70 to 80 questions that are asked in the beginning of using these tools. And from the knowledge of the historical projects, what the tools are really doing is that they're collecting information from thousands of real projects and consolidating it and saying your project matches the pattern of these other projects. And here are the results based on actual projects that have been completed where you have historical data. So they're not making stuff up out of the blue. They're analyzing historical projects and giving you a simple way of gaining access to the stored knowledge of a big section of the industry.
So they're basically saying if the trend of the industry hasn't radically changed in this past year, then your project is likely going to land with a certain number of defects, certain number of lines of code, et cetera.
Yep. I like to use this analogy with medical, but the set of questions asked about a software application are similar to the questions your doctor asks when you do a complete medical examination. Have you had headaches? Have you fallen? Have you been dizzy? The same kind of questions for software projects would be asked by a medical doctor during a diagnostic workup. But we're trying with these software tools to diagnose problems in software applications rather than people.
Right. Because they rely on a lot of data as well as symptoms versus diagnoses and likelihoods.
Yeah, but they have hundreds of years of data, and we have
That's true.
Barely 50 years.
That's true. How much of the data is in the last 10 years versus the previous number of decades?
The data available to me from the stuff that we've actually gathered is about 27,000 projects. And there was a big gap in 2020. But up until then, we were collecting data from maybe 2,000 or 3,000 projects per year from maybe 40 or 50 companies.
Okay. Is there something that a team could do to submit their past projects to be included in the research?
Normally, they commission a measurement. A company would commission a study to come in and collect the measurements for them and teach their own people how to do it. And one of the byproducts of doing that is you get access to the data. But when a CEO is not happy with the quality of software that their company is producing or the productivity or the cost, they try to bring in outside consultants to see if they can straighten it out. And it's the outside consultants that collect the data that later feed into these estimating tools. So being a consultant, trying to, from an understanding of what could go wrong with software and helping clients eliminate the weak parts, you also end up collecting the data that you need to generate accurate estimates.
Gotcha. Okay. Well, I want to circle back a little bit to function points, because I think that there's a lot of people that I talk to, I've heard the term function point, but they consider it to be one of the older techniques, of decades gone by. How can they apply that today?
Well, first, function points are younger than COBOL and younger than Fortran and younger than Basic Assembly. They're about the same age as Java. So saying that it's the old one is not quite correct. Also, the International Function Point Users Group has thousands of members in over 50 countries. And function points are the most widely used metric in the world. And there's more than one International Function Point Users Group. There's also the COSMIC group, as well as the IFPUG, International Function Point Users Group. So if you don't want to use function points, give me a suggestion. What would you use? You can't use lines of code because that penalizes high-level languages and makes assembly look cheaper than Java. You can't use cost per defect because that penalizes quality. And when you get zero defects, you have an infinite cost per defect. So you tell me what metric will actually measure both quality and economic value other than function points. And I'll bet you can't name one.
Yeah.
And if you don't measure anything at all, if you were a medical doctor, that would be like treating a patient without taking a temperature or taking a pulse or anything like that. That would be called professional malpractice. So anybody that doesn't want to measure is, to my mind, guilty of professional malpractice and should be in some other kind of work.
Yeah. So how can, for someone who's never used function points before, what's the recommended path to get started counting?
Well, you can hire consultants to do the measurements for you. In fact, not everybody needs to understand the actual rules of counting function points. So it's probably better just to bring in a consultant and have it, or one or two consultants have the work done by them. Or they could also teach a cadre of your people. If you're a big company like a Microsoft or an AT&T, they have internal measurement teams. And it's the measurement teams that has to understand how to count function points, not every developer. And in all the companies I work with, the measurement teams do understand function points.
Mm-hmm. Because all the data, at least the part that I've reviewed, there's a lot of numbers with averages per function point.
Yes, and ranges above those averages.
Mm-hmm. So without understanding the basis of function points, and it seems like it's harder to understand the results of the research.
I don't find it hard myself. And anybody that's actually learned the rudiments, it's inputs, outputs, inquiries, logical files, and it's counting up those entities and applying a quotient to them. And it isn't very hard. You've got to look at the inputs that's coming into your system, whether you use function points or not. Mm-hmm. You need to know the outputs that are coming out from it. You need to know if there are going to be queries made from it. You need to know the logical file structure that's going to have. Everything that function points use are things that you have to know if you're going to build the software in the first place. It's just that function points apply a coding scheme to things that you should already be trying to understand.
I wouldn't consider myself to be formally trained on function points. Is more self-taught, and I do the counting. And the one thing that I've never been sure if I'm doing right is applying the multiplier. I can count out the individual. Yeah. It's like, okay, am I choosing the right multiplier?
You can also acquire function point counting tools that do all the math for you very easily. In fact, that's a lot less time consuming and less labor intensive than trying to count by hand.
Do you have a favorite tool?
Well, I build tools like that, so that would be not something I want to mention. Just do a Google search on function point counting tools and pick out any of them.
Mm-hmm. So in our software architecture practice, we've used the function point counting method, and then also just a decomposition method and this only works for smaller applications or mid-sized applications. We're listing out listing out every single behavior and getting two people to kind of
every single one.
Yeah. Yes. Every single function, which doesn't work for large, really big applications, but then getting someone to create a subjective estimate for how long would this take. And then we've taken the two methods, the function point counting method, and then just the subjective, how long would it take method. And when the two don't agree, then we're like, okay, are we missing anything? But then when the two methods agree, then it kind of gives us a high level of confidence.
Well, I have a series of papers and some stuff in my books that start with this: 1 function point, 10 function points, 100, 1,000, 10,000, and 100,000. And then it shows the average schedule for each of those plateaus, the average number of bugs, the average staff size, the average number of pages and requirements and design. And that kind of information is widely available in book form and in tools that can do the calculations for you. And essentially, once you know function points, you know how many pages of requirements you're going to need, you know how big the design is, how many bad fixes you're likely to have. It gives you a host of information.
Yeah. I think I keep on remembering that I think it was the Stack Overflow 2018 developer survey, and maybe you have some research on this that also that suggested that about half of the developers in the industry today have 7 or fewer years of experience. That means that since 2013 or 2014, the number of programmers has doubled in our industry. Do you have
the number of programmers goes up?
The number of programmers? Which
I haven't kept recent count since 2020 in that kind of data. But I think that because of the disruption of the business world in 2020, so many companies closing down, working remotely, that has reduced the growth in software populations. And we haven't come back to the pre-virus levels of increase in our personnel yet. We probably will, but right now, the data was murky. It was hard to get, and the gap in 2020 means that really I can't give you a current answer because there's all the data is kind of stopped cold in 2019 and hasn't come back yet.
Mm-hmm. Well, even if we've stalled and kind of haven't continued the growth with so many new programmers out in their industry, there's practices that and some of the results of your research aren't particularly new trends. They've been trends for for a couple decades now. That there's a whole population of developers that need to be brought along and realize that, hey, there's some long-standing research results that still continues to be true today. Even though frameworks and technologies change and we're on to the new and the better, but yet there are some things that continue to be true.
Well, I would think that the university professors that teach software engineering are teaching better practices today than a few years ago. I'm old enough so that University of Florida had no computers, had no software engineering, and they had no way of teaching it. So we had to learn from the companies that were in that business, like IBM. And but today, you have almost any university, MIT, Florida, Harvard. They have excellent schools, excellent training for their software people. And for that matter, the bigger companies have internal training that's pretty good too.
Right. I wonder if we have any data for how many programmers today who are practicing today did go to a university, and how many programmers today went through a trade school or a programming boot camp instead.
It's a good question, but I don't have an answer to it. I've been more concerned with studying quality and reliability and bugs rather than the demographics of the industry, so I haven't done much research on that. But I like the question. I think it deserves an answer.
Yeah, anecdotally, I know that I run across a lot of people who've gone through the coding boot camps, and there's from 9-week programs to 6-month programs, versus 2-year associates or 4-year bachelors. And so now, we're all over the place with practicing programmers who had very different education paths.
Well, recall that the Software Engineering Institute was created in part to improve the training that was not available at the time in academia.
Mm-hmm.
And the bigger companies, the AT&Ts, IBMs, General Motors and such, their internal training for their own people is as good as most universities, I think.
I believe it. Yeah. On-the-job training, and then there's intentional on-the-job training.
Yeah.
So, awesome. Well, why don't we close just kind of circling back to your latest book, which will come out soon. Have you mentioned everything that you wanted to about the content there, or are there any other topics for people to watch out when they can get their hands on the book?
The new book covers some of the things we've talked about today. How do you distinguish patterns at work from patterns that are going to cause trouble and cause grief later? And for example, failure to do inspections is going to cause grief. So it's basically in book form, more or less like our conversation today, with the same track. Things to look for and do right, things to avoid and stay away from.
Right. Awesome. Well, Capers, I really appreciate the time to come on the show. I've been a reader of your books for some time now, and a student of your articles. So it was a personal joy for me to have you on the podcast. Thank you.
Thank you very much for inviting me, and I appreciate the invitation, and I hope that the information will be of use to your listeners.
Oh, I'm sure it will. And thank you, listeners, for tuning in. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.